Hello, this is a video about digital watermarks. Digital watermarks are code added to a digital audio, video, image, or document file. In this video, we will look at the three-step process that is involved with digital watermarking. We'll also look at some terminology, visible versus invisible, fragile versus robust, preventive versus detective controls, and then we'll look at some examples about how digital watermarking is used. There's a three-step process with digital watermarking. The first step is the embed process, and this is where a file is embedded with some digital watermarking code. The second part of the process is modify, copy, replace process. And this is where the file is sent over the internet, posted on YouTube, it could be photocopied, anything could be done to the file. The third step in the process is the extraction process, and this is where special software is used to scan the file and the digital watermark code is identified. Let's take a look at some of the terminology. Visible versus invisible. Visible digital watermarking is viewable by human eye or detectable by ear. And the picture on the right is an example of a file that has a very visible digital watermark. Another example would be a black line running through a video file. Invisible or imperceptible digital watermarking is only detectable with special software. And again, the file on the right could have some digital watermarking code in it that you cannot see with your eye. Another example would be a high frequency noise that you can't hear that would be added to an audio file. Fragile versus robust. Fragile digital watermarking is corrupted if any part or even a small portion of a file is modified, and this is used for tamper detection and data security. Robust digital watermarking is protected and can be extracted if any part or all of a file is modified, and this is used for copyright protection and ownership protection. Controls. Preventive controls, by definition, are processes designed to deter errors or irregularities from occurring. And digital watermarking cannot do this. No file is 100% protected, and tampering cannot be 100% prevented. Someone will eventually find a way to copy or tamper with a file. Another kind of control is a detective control, and this by definition means a process designed to identify if errors or irregularities have occurred, and this is something that digital watermarking can do. So let's take a look at three applications of digital watermarking. The first one is copyright protection and verifying authenticity and integrity of files to show ownership. The second application is data security of official documents, and the third application is forgery and tampering detection. Copyright protection. Now, the goal here is to detect unauthorized distribution of images, audio, video, and other documents. Owners can copyright their work by inserting digital watermarks within a file. If another person claims ownership to the file, then the digital extraction process can identify the true owner. It is claimed that owners could also control distribution of their file by inserting code that prevents copying, but this is not 100% effective. There's always someone who can figure out some new technology or some new way to bypass the code. So I'm going to cross out this particular bullet point here. The second way that digital watermarking is used is for data security, and the goal here is to certify and authenticate a file. On the left is an example of a protected ID card. The ID number 200000021444307 is written in plain text on the card. It's also barcoded, and it's also hidden as a digital watermark in the photo. This means that the key information is written 3 times on this ID card. If anyone tries to tamper with the card or replace the photo, it would be possible to detect the changes. Special scanning software could verify the proper links with the digital watermark hidden in the photo against the barcode and against the plain text on the card. The third use of digital watermarking is forgery and tampering detection. And the goal here is to detect any modifications made to a file. Image A below shows an original photo of a car that has been protected with digital watermarking technology. Photo B shows the same photo with two numbers modified on the license plate. This looks like a pretty good forgery, doesn't it? Photo C was produced after running the tampered photo through a digital watermark detection program, and the tampered areas are identified in white. Not all uses of digital watermarking is for protection and security. I thought I would end this video on a more interesting application of digital watermarking. Bag Makers Inc. is a cloud-based company that sells bags with imprinted logos and photographs, and they have developed a technology where they can apply a digital watermark code to a full color photograph. The code is invisible, unlike a QR code, and when the photo is scanned by a cell phone or another mobile device, the digital watermark code opens a website, a video, or a sign-up sheet for membership on the mobile device. This is a great application of digital watermarking for trade shows, open houses, and advertising.